Hi, good morning. Welcome to our venue, and we will be the first presenter today. And I'm from SciCloud. My name is Han Jiayao, and this is my colleague Zhang Xi. And basically, in our presentation, we will talk about how we use Peak Flow to make the national grid smarter. And in Peak venue, and how will we talk about a more traditional industry, that is the power generation and also power utility industry. But actually in China we have a lot of changes. We have a lot of traditional industry, traditional SOE and also traditional enterprises, but they are all embarked their digital journey to move more online and onto the cloud. When they are doing it, it is because of the market competition. In China we have very fierce market competition. If they don't embark on the digital journey, then they will be surpassed by other latecomers, for instance, like the internet startups. And therefore, they need to embark on the digital transition. And this means we will have new application scenarios. And if we look at the data, so for the GPU market, actually compared with 2017, it enjoys a growth rate of 230%. And if we look at Deloitte and also Forbes and also McKinsey data and also their survey, actually they all found that in the future we will have more AI and also more machine learning and relevant devices. So we say that AI and also machine learning now has permeated into every aspect of our life. And our national state grid also at this cross-section. So in terms of power generation and power transformation and also power transmission, and also in the end, the end users, and during the whole journey, actually there will be massive data and AI and also machine learning can play a huge role here. And these are some examples. For instance, in power generation and also in the smart patrol, and we can use AI and also ML to do a lot of things. For instance, we can use a monitor surveillance camera to do the monitoring. And also this is the end user's behavior. For instance, we can forecast what is the trend of the future power utilization. And this is the power generation at, for instance, at the thermal power station, and we can use AI to monitor the exhaust gas temperature. And also in the hydropower station, we can monitor the water level in a more smarter way to prevent any flood. And also we can use computer vision to detect the status of equipment, devices, and also the whole system. And also for some non-core department, for instance, the physical department, they can use OCR and also computer vision and to identify automatically the invoice, and also to forecast the future financial flow. So we have talked about many application scenarios, and they encounter a lot of demands in terms to operate more smartly, and what is the traditional way of doing it. But they usually will find a third party and to sourcing all their data and also information to the third party, and it's like this vendor, and the vendor will provide an API or a black box of an algorithm to the state grid and also other enterprises. And if the application scenarios is changed or the data is changed, and for the black box algorithm, it is very expensive to buy, and how to tweak it. Actually, it is a black box. It's very hard to adjust or to tweak by yourself. And also for many enterprises, they don't want to just give away their core information, core data, and also their core innovation to the third-party vendor, and they simply don't want to do that, because for them it is the most important asset and also core competitiveness in their enterprise is data, is information, and also innovation. So for the enterprises, actually they want to have more controllability to do the development and also to better utilize the new generation of AI and also machine learning. And many people say that now we have a lot of open source and also algorithms. And for instance, we have PyTorch and Puppy and TensorFlow. They're all open source, and it's like lowering the threshold. But we have a lot of framework, a lot of architecture. Which one do I choose, and how can I compare between them? So for many enterprises, when choosing which one to use, they face a lot of pain points. And also for many large-scale enterprises, they say that, well, I can set up a algorithm team or architecture team by myself. But this does not mean that they will not encounter any pain points because it concerns efficiency. For instance, this is our client Suning, and before the Bolt 11, they require we provide them a new system. And also for Starbucks, they require that before the end of October, they need to have this new framework, new architecture. That means there will be an increasing of amount of data, and how can we develop in a very short time the architecture and also the algorithm and put it into practice. And artificial intelligence, because of the neural network development, and we have a lot of improvements in terms of algorithm. But actually, the neural network is very complicated, and it requires a lot of computing capacity. This means we need to have more time to train the framework. And last challenge also comes from one of our clients in power generation industry, and this is a concrete case. And I think this is an Excel spreadsheet, and I don't know whether you can see it clearly. So what does it record here? Actually, it has this enterprise has 400 GPU, and how to assign to the 20 model in the pipeline. And here is one line, if you can see clearly. It says that in the afternoon of 16th, the GPU was assigned to the models, and it will be finished by the afternoon of 20th. I think many of you come to KubeCon, and we have a lot of case sharing and also best practice sharing in the past 2 days. So one manage the GPU resource and also Java resources. Actually, we have come into an era of cloud native. But here, when we are trying to manage the GPU and concerning AI and also machine learning, it's like we are still at the prehistorical era. So this is a big issue for all of us, and it is a concrete case provided by one of our clients. Well, we have a lot of pain points and also challenges ahead of us, and I think we are all very familiar with these pain points. And this is the Workbench. In 2018, they released the enterprise report, and we all know that the classical software development, basically it is a two-dimensional issue. We know the purpose of the software, and then we know the architecture of the software. The rest of it is really simple. We just engineering it to implement it. So we have X-axis and also Y-axis. But the new generation software development, apart from taking care of the legacy, but also we need to think about data processing and also model comparison and parameter adjustment, and also the relevant neural network. So it is more than 4-dimensional, even 5-dimension, and that means we need to think about the time. We need to think about the time cost, the cost of time, and it will be dozens of times compared with the previous era. So Cai Cloud, what are our solutions? So I will invite my colleague Zhang Xin to talk about it.
I was choosing my recital, but it seems like a lot of challenges, right?
那刚才的话呢，我们是讲到了很多的痛点，很多的挑战。
To turn the pages. All right, and I'm going to do it So this diagram
那
actually
我们在这边的话呢，是有一张表格。当我们讲到基础学习或者 AI 的时候呢，很多人其实会有误解，那觉得说 ML 的话呢，就是有关计算、有关算法。那其实的话，它可能在一定程度上是真的，但是真正的当它落地运用的时候，其实不只是算法了。所以的话呢，我们在这边也有开源，比如说 PyTorch， 还有像 TensorFlow。那在这边我们也是有些听懂、有些挑战。那我接下来还是用中文来进行演讲。So as you can see in this chart, just now we talk about machine learning is about 4-dimensional. So in the middle we have a machine learning code, and apart from it, we still need to think about data processing. And also when we're faced with massive data, how can we allocate resources, and also how can we shorten the life cycle, and all of it we all need to think about. So machine learning is not only about algorithms. And luckily, from last year, we began to realize the pain points, and Red Hat and also Google and also PyCloud together we come up with a new solution that is Kubeflow. And Kubeflow is based on the Kubernetes and also its relevant cloud native, trying to solve all of the pain points, including AI development and also AI iteration and also the AI online production management. Although we have a Kubeflow, but still it's still in its infancy stage. And currently the Kubeflow features and functions are as follows. First of all, it has the distributed computing structure, and in order to shorten the model iteration cycle. And also we have a Kubeflow pipeline sub-project. We can use it as well, config, and to have an end-to-end machine learning flow. And apart from training, apart from this flow, and when we implement the project, we also found that for traditional enterprises, we need to provide them with more features and also more factors in order to facilitate their digital transformation. And first of all, what we learned, the most important thing is data. And for AI development, the most important asset is always data. For instance, how to collect data, and also how to unify the format, and also how to do data washing and also data verification. But if we do not have a very valid data labeling platform, data management platform for traditional enterprises, they are still using the traditional way, like manually search, manually input their data, and to manage the data manually. And if we continue to use, and if we have this data, and we still need to think about how to train the data, and I think we still need to put in a lot of effort here. We need to do the error and the trial, and to experiment with the data, and also we need to tweak the data when the result is not satisfied. So during the way, and in the scenario of software development, and when we face difficulties, usually we need to have a second pair of eyes to provide a new perspective. And that's why we need to talk about coordinated development. And in the level of configuration, software, and also algorithm, we need to have a way to share. We need to have a shared platform. And we still lack this common platform to share. And if we have the good luck, and if we have the best and the most suitable model, then also this model needs to be integrated in line into the cloud and to be accessed by our clients. So we have a Kubernetes, we have a containers, and it's really easy for us to release the software. But for engineers and also for software developers, actually, they know a lot about algorithm, but when talking about commercialization, when we talk about engineering, actually for our software developers, they still lack a lot of skills in this end. And even though we solve the issue of a deployment, but also we need to think about we should not only to guarantee the unification of the production scenarios, but usually we found that when we have under the development scenario, we have a 99% accuracy. But if we let the clients to use it, actually the accuracy rate will be lowered. And if we don't use a container to solve the issue, then the accuracy rate is even lowered. And the headache is that if we have go through all the difficulties and to have the flow, and we have new data coming in, and with the changes of the data, the model needs to be iterated as well, and also the speed of iteration need to be even higher than Java. And when we have the new data and we need to have the new model, all the pain we suffered, we need to do it again, and therefore we need to think about how to do the CI and also CD in a very fast way. And when we have the new software, and then we need to monitor the reliability and also the consistency and also the resource consumption of the model, and also because the behavior of the consumers is changing and also the data is changing, we need to think about whether the model is as accurate as we expect. And Kubeflow provides us with a very good starting point. But for traditional industry like electricity generator, and we can use Kubeflow to establish a new architecture. So this is a new concept, AIOS. We do not want to compete with Microsoft, but we need to ride along the opportunity. And we have an operating system that is for AI. So we have the system operator, we have the data scientists, and also we have the data engineers. So we want to use the AIOS to enable all these three different steps. And also we have, for instance, data and resource management, and also streamlined and interactive pipeline, and also we have the distributed and orchestrated training and integrated model to business loop. And if you want, you can take a mobile phone to take a picture of this slide. So this is based on Kubernetes, and we follow the open source, and we use Kubernetes to solve our pain points in resource management, so PV and PVC. And also it can support different application scenarios, and also it can better synergize the different working groups. And also based on Kubernetes, we use CRD and also operators, and to realize to support the DevOps and also the agility, and also with Kubeflow, and we can accelerate the PyTorch and TensorFlow, and also we have the operation interface, and therefore for the staff from the traditional enterprise, they can use this interface to operate it. And when we apply the AIOS to the power generation industry, it's like we provide them with a smart terminal, and in the Kubernetes we can store all of the data formats required by the power generations, including the transmission, financial physical data, and also operation data. And just now Julia talked about the different scenarios. For instance, we can apply this to, for instance, the monitoring and also tracing and also the generator maintenance, and in different scenarios. And lastly, please watch a video. So, for instance, this is an interface, and for the operators, they can create different operating space, and we have operators, we have managers, and also we have developers. And through the online environment, we have the multitasking, and all of it is processed in an automatic way.
With the data available on top of the user interface, we will be able to tag and wash out those data. Behind all of the user experience, we have used a lot of open source technologies. We will also be opening up some of our in-house technology to contribute to the whole society of the industry in the future. And we can also modify and edit the modules. After the simple configuration on the lower hierarchy, Kubernetes will be able to initiate training tasks, and you can also run them in parallel. You will be able to automatically adjust and allocate resources among the different tasks and jobs. We also have a multi-dimensional dashboard, not only on the utilization rate of the resources, but also on the effectiveness of the model. In the end, when you have a relatively complete model, how can we turn into a system that can be launched? We are familiar with the microservice, service mesh, container, and the Runtime and gRPC APIs. We will want to put everything together, and it will become a system already launched online. Lastly, I do want to say thank you to all of our colleagues who has been contributing to our programs and projects. I also would like to say thank you that this is the first time I'm giving a keynote presentation. I think the best advantage of giving a keynote is there won't be any hard questions for you. So anyway, thank you.